Hey, welcome back. This is episode 2 of the Uptime podcast. I'm your co-host, Dan Blewett, and I'm joined here by lightning protection expert, Alan Hall. Alan, how's it going out there?
Great, Dan. How are you?
Good. So what's the latest on your quarantine?
Everybody's still quarantined. They just announced the other day that the schools are all closed until May 4th. Everybody was supposed to go back April 7th, roughly. So they pushed it back another 30 days. So we're going to be in self-isolation at least another 30 days. And then they closed all non-essential businesses, which means pretty much everything is closed around here right now.
Man, what's your family doing to stay stir crazy or to keep from going stir crazy?
Well, for right now, we're trying to get outside a little bit. It's actually close to 60 degrees today, so it's nice to see some sunshine. Yeah, I know. Tell me about it, right? So, earlier, not very long ago, it was a blizzard outside, and now we have some decent weather. And I just got a couple of texts this afternoon saying that people are heading outside to get some of the sunshine. So hopefully there's a little bit of a turnaround. Otherwise, if we get stuck in the house for another 30 days, it's going to be trouble, I have a feeling.
Yeah. Have you ever played any of those? They're like these electronic sort of like family home games. I think they're by Jackhole is the company. There's one's called Quiplash. They're kind of like you can do it on like Xbox or any of those systems, but you can also play on the web. And I think it's like a subscription fee. My brother-in-law has it, my sister. But you all like sign in. So you create a room, and then everyone has like a room code, and you go to the room code to the on their company's website.
Yeah.
And you all enter the room code. So then you're all in, and then you use your phone as like your playing device. And so there's like trivia ones. There's ones where you all draw a thing and then it like uses it and you try to guess who drew it, or you get like, there's lots of really quirky, it's pretty fun. I mean,
I haven't heard of that. Well,
yeah.
anything to kill the time right now. I mean, we're looking for everything.
Yeah. So I think my family tonight, we're going to try to do a Zoom call and screen record that. So I think if we screen capture the game, we all logged in on our phones, I think it should work. So we're going to try that out. But yeah, it's a fascinating time right now.
Yeah. You're speaking about Zoom and everything together. There's been so much Zoom calling going on. It seems like the internet has come to a crawl. At least in Western Massachusetts, it's really slowed down a good bit because everybody's trying to do work from home and doing video calls, which is good, right? I mean, at least we have the option, but it does slow down the internet.
The old interwebs is heavily loaded at this time.
Heavily loaded, yeah. There's a guy in front of the house this morning fixing the internet cable, and I thought, well, okay. At least the repair guys are still out there. I'm sure they're pretty busy because any sort of outage is going to be a crisis right now.
Yeah. Yeah, I mean, if people lose internet and they lose Netflix and Hulu and all that,
it's trouble.
The world is going to literally implode like a dark star. It's going to be a mess.
Yeah, it's going to go bad fast. Yeah.
So you mean I have to talk to my family and friends? You mean I have to play board games? I have to read? We're not capable of doing that as a society. Yeah. Not today.
Not today. No.
No. So last episode, we talked a little bit about the growing size of wind turbines, and you can probably tell my accent. I call them wind turbines, but I'm going to start softening that eye. With these wind turbines getting bigger and bigger and bigger, blades are getting bigger and bigger and bigger. The composite materials are extremely durable because they have to be. Yeah. So we sort of briefly mentioned some of the issues with blade waste. So when these turbines go out of commission, those blades have got to go somewhere. So we were chatting about this off camera. How big of a problem is this for the industry right now?
Well, it's just really starting about now because based around when the wind turbines went up, it's roughly a 15, 20-year lifespan. So back in the early 2000s, particularly in the United States, there's a lot more wind turbines going up. And so they were starting to reach their useful life, and we're pulling the blades off and taking the towers down, the cells down, and then trying to dispose of the blades. I've seen a couple of interesting articles. I think there was one on Bloomberg the other day where they're talking about essentially burying the blades, putting a deep hole in the ground and putting the blades in. The blades are made out of mostly fiberglass, some sort of resin system, epoxy, or it's mostly epoxy, some sort of plastic like that. And balsa wood is a big one, right? So balsa wood is used as part of the reinforcement to make it a stiffer structure. And then there's some metalwork and things kind of down at the bottom where it attaches to the hub of the wind turbine. So they're essentially burying them. I've seen a couple of places where they've chopped up those wind turbine blades and are trying to rebuild other things with them, which is possible. I mean, it's be fiberglass, chopped fiberglass, which they can use in different things. But I haven't seen. They're so massive. I think the killer right now is they're so massive. It's hard to just easily dispose of something that big. So it's a struggle right now. It really is a struggle.
I mean, you look at the size of them, especially as you're just driving by, a car or something, especially the more, the onshore wind farms aren't nearly as big as some of the gigantic offshore ones.
Yeah.
But even then, I don't think you really get so I was out flying a drone, getting some footage and taking photos of these for some content that, you and I have been creating.
Sure.
And you don't really get a sense of the scale of these things until you're up close. When you're up close, I was in this wind farm in like West Virginia, and I was getting really close to it, and I was approaching on my car. And then I went up this hill, and then suddenly there were no turbines in view. And then as I got to the crest of this hill, suddenly one just was there. And it was almost like scary. You're like, oh my God, like that thing is enormous. And when you really get up close, you start to see the gravity of just how big these things are. And you start thinking about repairing them and installing them, just all of this stuff. I mean, they're just massive machines. So as the scale keeps increasing, what other problems is the industry facing with scale?
Well, there's a couple of bigger issues right now with scale. One in installation. So if you start from when just manufacturing something that big gets very difficult because you just need the tooling for it to make it something that big. And then once you make it, how do you move it?
Yeah.
So a lot of times factories are built nearby or relatively nearby where the wind turbine farm is going to be. So they can usually take them by truck and truck them over to the final destination. I've seen a lot of things, I think in Belfast, Northern Ireland, they've been doing things where they're making blades and then putting them on ships and then shipping them out from there. Because it's hard to move something as massive as these wind turbine blades. And then the cells and the towers, the same thing. It's all the same problem. Up here in sort of Western Massachusetts, where it's pretty hilly, they have to put in roads so the trucks can make it up to the top of the mountains where they're going to install the wind turbine blades. And then obviously there's a lot of infrastructure that has to happen to mount something so massive so it doesn't tip over. There's concrete work, a lot of groundwork has to happen. And then once it's installed, obviously you have big cranes. So everything just gets massively larger, and particularly as you get out in the ocean. Same thing. The cranes and the machinery it takes to put these things together just gets massive.
Yeah. I was watching a video. I think it was on Instagram. I'm sure a bigger clip is on YouTube, but they were taking this huge blade and trying to get up this windy mountain road. Yeah. And it was on this truck that could raise the blade vertically so that it could accommodate some of these, really sharp turns. Sharp turns that you would have to slow down just driving in a little Coupe de Ville or something. So, and I was looking at the mechanism on this thing and I'm like, good grief. Because it's the same as like when you have a pretty long couch and it won't fit, horizontally down. And so you have to lift it up with your partner and it's the worst thing ever.
It's exactly like that.
Yeah. And you're doing that on a massive scale on a truck. And you wonder, all right, well, when that blade goes to its most vertical position, whatever that is, those trucks probably can't have much margin for error.
No.
They're going to tip. No. If you get a big gust, it could blow the whole truck over. It's going to be really scary.
Yeah, and if you ever watch one of those things go down the road, there's a lot of people in front and back. And as they go up particularly here where you can see them go up the mountains, there's a lot of people watching on either side and around. And the winds have to be just right. And you have to find the right day. It can't be snowy outside. There's a lot of things that have to go in your favor to get the thing put together. It's not just as simple. And many years ago, I kind of worked on a program where they were going to take basically an airship and lift up things like this wind turbine blades and just basically pick them up at the factory and fly them where they got to go and then drop them down. And of course, that never happened. But in an ideal world, that would be something you can do, because if you go across the Midwest in the summertime in particular, most times, like you're going down Interstate 70 or Interstate 80 in the Midwest, you'll see wind turbines on trucks going up and down the highway. Yeah. There's a lot of them.
Mm-hmm.
It's surprising at the number they can produce in any one time. But and just thinking about sort of the scale of management of something like that, it takes a lot of organization and a lot of coordination to do that safely.
Yeah, and so when you think about, how long, all right, so it's so painstaking and expensive, requires so much manpower
Yeah,
to get it where it needs to go.
yeah,
Then once you finally install it, obviously you want to take every measure and every precaution to keep them just in service. So you don't have to replace a dang blade somewhere down the road. So, what are some of I know there's tons of redundancy on them and there's lots of engineering,
yeah.
but what are they doing besides, not just lightning protection, but just to keep them in service as much as they can and can be?
Well, when they started, one of the things they obviously have to do with any sort of composite structure, be it an airplane or a wind turbine blade or even Corvettes, which are made out of fiberglass for a long time, is you want to make sure that that structure is sound, and it's a little bit different than something that's made out of metal, where you can kind of see a deformation or things of that sort. What you're seeing in a composite piece is there's multiple layers of, in this case, fiberglass and balsa wood inside. If those layers internally start to buckle with in respect to one another, or if they become what we call delaminated, so they start to separate over time, that's got to get fixed.
Mm-hmm.
And originally, and the way it started was they would put repair people or inspectors on ropes, and they go down and you can kind of tap test, or there's a bunch of visual techniques that you can use to inspect the blades. And so they would go up and down the blades, each of the blades, to make sure structurally everything is still okay. Because your worst case scenario is you miss some significant structural deformation, degradation, and that blade goes bad and it breaks, right?
Yeah.
That's sort of your worst case nightmare, because the cascading effects are expensive. So, but more recently, what we're seeing is a lot of robotics being used, cameras on drones, or drones that are physically attached or somehow stick to the blade and kind of climb up the blade.
Yeah.
They're inspecting the blades that way to get some better assurance of the structural integrity of the blade, because ultimately, in any composite structure, the key is just to keep following up and repairing them. If you keep them in decent shape over time, you can extend the lifetime. If you abuse them, not take care of them, like anything you have that takes a lot of wear and tear, it's going to shorten its lifetime. So
Mm-hmm.
there's a big emphasis on maintaining, inspecting. You're seeing a lot more. I think just because of the ease of it, because we can do things robotically with drones and with really high tech cameras, we can do a lot more inspections, and it's a lot faster than it used to be. So I think the number of inspections and the quality of inspections are going to go way up, which will also help extend the lifetime of some of these blades.
Yeah. It's interesting. You talk about drones. I was reading an article about the DJI company and their founder, Frank Wing,
Yeah.
who is still a young guy. He's, I think, in his mid to late 30s. But DJI owns 77% of the U.S. drone market. I mean, they're just
Yeah.
far and away. They've just
Yeah.
destroyed their competition. I mean, I think
Yeah.
their next biggest single company competitor is 3% share of the U.S. drone market.
Wow.
Yeah, it's a huge, and they said it's almost problematic because their DJI is almost now competing with themselves on pricing. They've
Yeah. I can see
done
that.
so much to price other people out of the market. Like DJI's drones are just better and they're cheaper now than others.
Yeah.
And now they're struggling to outdo themselves almost on price. But there's a new competitor in the drone market called the Impossible Drone, where their CEO worked for Tesla, and he's actually building the
Ah,
frame of these drones out of a battery. So you can basically pack way more energy storage into this drone rather than having removable battery packs. So I guess the Impossible Drone right now claims about 2 hours of battery life, of
wow.
flight
That's really,
time, versus about 30 minutes or maybe a
yeah.
little more for a DJI drone, which is
Wow.
really interesting. Yeah, I mean,
That's
especially.
a good conceptual thought. So they're actually taking the structure, and making the structure rechargeable. Is that what it is?
Yeah, because they said, I guess with Tesla cars, the battery is integrated, or it essentially sort of is the frame, and that's how they have
Mm,
such a low center
yeah.
of mass,
Yeah.
and
Right.
they can
True.
do such. I guess they have really good cornering and acceleration and stuff like that because of it.
Yeah.
So kind
Yeah.
of applying those principles to the drone, which is really interesting.
Wow. Yeah. Well, obviously, drone lifetime and battery life for anything we're using
It's
today
huge.
is just totally huge, right? And if you can extend the life of a battery or keep a drone in the air longer, it just makes things so much more efficient. Yeah.
Yeah, and of course, the one
Hmm.
caveat that I was thinking of as I was reading is, like with camera in the camera market, like we have cameras rolling, and with like all the wireless audio, almost all of those pro model audio recorders and receivers and lavalier mics, they actually run off replaceable batteries, and
True.
this is the thought is that if your drone is the battery and it doesn't have a rechargeable, replaceable battery that you can pull out and pop in a fresh one,
Yeah.
then you're limited to 2 hours and then you have to stop and recharge it. Whereas if you have a
Right.
DJI, another drone or any battery operated thing, sure, it might only be in the air for 30 minutes, but if you have 8 batteries, you can be in the air for 4, 5, 6 hours if you're in a really remote location, whereas
Right.
you don't have to stop and actually charge it in. So I guess there's give and take with whether plugging it into it, the
Hmm.
device
That's a
itself is
thought. Yeah.
better
Sure.
versus having the rechargeable. Because, if you're an audio guy or an audio girl on set for 10 hours and you're in charge of the mics,
Oh yeah.
you got to replace the batteries. So you
All
can't
the
you
time.
can't sit and these $1,000 microphones and microphone receivers, you can't put them down and charge them for
No.
2 hours
No.
while you grab your other $1,000 one. Like, you need to just
Right.
pop new batteries in and go. So it's an interesting kind of back and forth with all that. So what else are they doing in the industry to help maintain, or what else is what other innovations do we have right now as far as maintenance?
So the big one for wind turbine blades right now is a, sort of a combination. It's making sure that the blade structure is there. So we're seeing a lot more work. Well, there's just three things actually. There's a lot more work in terms of inspection. So the drones are really big, and the cameras that are using the drones, and some of the thermal aspects there. You can use some thermal cameras to do some inspection.
Hmm.
The second is the what kind of fiber is going into the blades. Because the blades are getting so large, they need essentially stronger fiber, and
Yeah.
that's carbon fiber. So they're moving away from fiberglass in some aspects and putting stronger fiber in. Carbon fiber has been used in the airplane industry forever, uh, but it's more expensive, and that's why your airplanes are so much more money than a wind turbine blade. So the wind turbine industry has been using cheaper materials, still acceptable materials for the environment they're in, but when the blades get so big, you need to put stronger fiber in. So they're putting carbon fiber in. And then the third thing is they're doing a lot of things on lightning protection, because one of the biggest structural damage causing events is lightning.
Hmm.
And so the lightning protection systems are changing over time. They're getting smarter, and they're retrofitting a lot of the wind turbine blades that are out in the field right now with better lightning protection. Again, to get into the longer service life, extend the blades out as far as they humanly can to get the most energy out of them before they have to remove them.
Yeah, no, that makes sense. And there's a lot of fail safes as well. Like I've seen a couple. I've
Yeah.
seen a lot of videos of when turbines, go wrong, whether they get hit by
Yeah.
lightning and they catch on fire, or the nacelle catches on fire, or
Yeah.
you've seen a couple of them where I guess they're in a storm and they get spinning so fast and they get out of control, and then they eventually just explode essentially.
Yeah, something's
Um,
gone wrong in those situations, right? Because the blades, they know what the wind speeds are, and they know how
mhm,
fast the turbine is spinning, and they have braking systems. So we have a couple different systems. So basically, you take the blades rotate and pivot, similar to a propeller on a lot of propeller-driven aircraft. The propeller actually rotates a little bit, so you can basically, it's similar to a sail on a sailboat. You
yeah.
kind of take the sail out of the wind, and it doesn't rotate as fast. They can do that. They also have essentially what it looks like a set of disc brakes inside the nacelle. So there's brake pads and a
Mhm.
rotor, and it just grabs hold of it and slows the thing down. When those things don't work, you have some sort of probably computer failure or some significant mechanical failure. Yeah, then it can spin to the point of going to catastrophic.
Yeah, those those videos are pretty intense, and
Yeah.
it's funny that people just, I guess some people that just live close, they just start to peek out the window and they're like, that thing's acting strange. Pull out their camera, and
Yeah.
then 2 minutes later, they're like, good grief! Like this whole thing just goes, and they catch that moment on on camera. But
Well, if you think about how much
it's
energy is
intense.
in one of those, when one of those wind turbines lets go like that, the weight of those blades and how
Yeah.
fast they're moving. And when it all comes apart, there's a tremendous amount of energy in that explosion. I mean, it's not dynamite, for example, but when that thing lets go, there's a lot of energy there. So you don't want to be anywhere near it. If you see something like that going on across the Midwest, you see people taking pictures of that kind of stuff. Again, I
Hmm.
think way too close
Yeah.
because you have no idea where those parts are going to go, how it's going to come apart. It's better just to let it get back and let it go.
Well, yeah, when they're just doing their thing and spinning at their normal pace, the
Yeah.
tips are still going 100 plus miles per hour. So
Oh,
they're
yeah.
visibly going way too fast. I mean, what are they, 200, 300 miles per hour at the tip speeds at that point? Before they're,
Well, yeah, when they let loose like that, they've got to be, right? Because
yeah,
I
going
think the tip
crazy.
speeds are roughly in the 100 to 200 mile an hour range, depending on the design of the wind turbine blade. Yeah, so if they get let loose,
I mean, they're
who
moving. Yeah.
they're going to go as fast until the structure can no longer handle it, and that's when it'll let go. So they'll go as fast as they humanly can, and then boom, that's it. It's
Yeah.
over. Yeah.
Well, and then the pole that they're attached to the ground with, I mean, that thing just
Yeah.
crumples like it's made of, like wet cardboard at that point too.
Well, yeah. Well, you think about the way that's designed. It's designed to take essentially load straight down through it and a little bit of wobble,
Hmm.
right? So there's some side loads it'll take. It's not meant to take, well, if the blade hits it, it's not meant to take that at all. I mean, it just buckles
Yeah.
it. If it has massive side loads, if one of the blades comes off, which tends to happen, one of the blades will come off and then there's a huge wobble. It can't take those loads either, and it basically self-destructs. It just folds over. It can't take those loads. It's made for normal operation stuff. But that's the thing I've noticed about the way those nacelles and the towers are assembled and designed. They tend to crumple, like they don't go spreading out all over the place. They tend to go kind of straight down. So from a
Hmm.
safety standpoint, that's exactly what you want, right? You don't want it flipping off and getting pulled out of the ground and flipping over to the next wind turbine, hitting the next wind turbine over.
Yeah.
It's if it all collapses around itself, you still have a mess, but it's not cascading, which is the worst case nightmare. You have cascading, particularly in a fire situation where it moves from one wind turbine to the next one. That's a big problem.
Yeesh. Yeah. So there's a funny soundbite of our current president talking about how dangerous wind turbines are to birds. How dangerous are they actually to birds? And do birds
Uh,
pose any threat to them, to the device itself?
the birds don't affect the wind turbines. I think there's sort of two schools of thought about it, and I've read differing opinions about it, and there's been a lot of research because birds dying around wind turbines is a thing, and particularly bats. The one I see mostly up here is bats. So the industry is doing a lot of different things to discourage birds and bats from getting close to them. I think the thing about it, and what I've seen more recently, is there's a sort of a suction effect that goes on. If you can imagine, obviously like on an airplane wing, right? The air moving over top of the wing is moving faster than on the bottom of the wing. It creates this sort of pressure differential,
Hmm.
and that's what in theory creates lift, right? So
Yeah.
on a wind turbine blade, it's a very similar thing. You get these big pressure waves, and the pressure waves are so massive that it can uh, uh, basically disorient or damage the bird slash bat, where it just essentially kills them. Those things, it's not really avoidable, right? If you get so close to the turbine, it's not something you can do. So some of the more recent research I've seen is ways to sort of discourage the birds and bats from getting close to the wind turbines to begin with, so such that those events don't happen. There's not a lot you're going to do here,
Yeah.
but it is important from just in any sense. The reason you're putting wind turbines up to begin with is to have a sort of a greener economy
Yeah.
and
You
something
care about
that's
the
efficient.
environment.
Yeah, you care about the environment, right? And the animals around us are important to us, so we need them as part of the ecology. So we're seeing a lot more. I think it was last summer I saw a number of papers talking about the bird bat situation and different testing things that are going on around and at least in the United States, where they're trying to discourage those animals from flying around wind turbines. And I think you're going to see some success there. I know the industry is monitoring it. I know people really care about it, and they should. So it's like anything else, like we're learning from the experience and making it better, which is what as engineers, we should be doing.
Yeah, we could have like a ball turret on the bottom of the turbine, and when something gets close, it senses them and shoots food the exact opposite way. So we just
Yeah.
go chasing it. These are
Well, I mean,
my big ideas.
yeah, well, if you're a bird or a bat, what else is moving at those speeds that's that massive at
Yeah,
that
nothing.
altitude?
Yeah,
Nothing.
nothing.
Right,
Nothing.
nothing is, right? So it isn't like next to the ground there's a truck coming by. I think a lot of animals at this point realize there's a truck coming by and get out of the way. But wind turbines are a new thing in their environment, and this takes a while for everybody to adapt to one another.
Yeah, that's it's an interesting dynamic between
Yeah.
trying to improve reduce our footprint on Mother Nature and
Yeah.
harvest these renewable energy sources while also not disrupting the ecosystem. Because
it's one of those things that I should pull some papers. In another podcast we should go back through it, because I do think there's some really interesting work that's going on in that area, and we can talk about that in specific, because we ought to give a shout out to some of the people who are actually working on that problem.
Yeah, I mean, it's there's just so many, you solve one problem and then you create two more little ones that you then have to address, and that seems like just part of the the industry expanding.
Yeah, totally. So one of the things that we've been working on here at WeatherGuard Lightning Tech over the last couple of months is we've been doing a bunch of research, in particular with wind turbine blades, and also as part of our strike tape product, as we've been going back and looking at some research. And I want to, during some of these podcasts, I want to talk about some of the things that we have seen, some papers, more recent papers that have come up, and particularly places like ResearchGate and those sort of research-oriented websites where people are starting to publish their papers. I want to talk about one today in particular because I thought it was interesting. I was looking through it again last night. It's called a review on experimental study of wind turbine blade lightning protection system, and it's produced by the North China Electric Power University in Beijing, China. And so you can find that paper on ResearchGate, and you can just download it off the internet. But they had a really interesting thing because they had tried essentially 3 different ways of providing lightning protection to a wind turbine blade. They metallized the very tip of the wind turbine blade. They put on 3 receptors along the length of the wind turbine blade, and then there was a sort of a third technique, which was it just involved looking at salts and that sort of thing, contamination on the surface. So they did some lightning tests on that, and the interesting thing about those different configurations, they thought, well, that's one of these has got to work. Like, come on, right?
Mm-hmm.
And what they found was that they were simulating lightning strikes to these different configurations, and they would test it. So the way this thing works is you have there looks like their laboratories outside. So they have like a 5.4 megavolt high voltage generator. So a high voltage generator is used to simulate the high voltage effects of lightning, and it also tells you where lightning is likely to attach. So it's what we call lightning attachment test.
Okay.
It gives this idea that, hey, is our lightning protection system working the way that it should? And is it as efficient as we think that it is? So when they ran these tests, one of the things they noticed straight out is the polarity mattered. So the polarity of the high voltage generator mattered in terms of the success of the lightning protection system. So from what I could read from the paper, because it's not exactly clear in the paper, but I just want to point this out, is that when the lightning generator was negative polarity, that means the blade is positive polarity. The lightning protection systems work really well. It doesn't really matter what the configuration is. When the lightning generator is positive polarity, and that makes the blade negative, they had a lot more punctures and randomness to where the lightning would attach on the blade. So that's something we actually see out in the field, as some randomness as to where lightning will attach to a blade. And it also seemed to matter. They did some really interesting tests, basically orienting the blade, whether it was vertically straight up, like the tip pointing straight up in the air towards the lightning generator, which is above it, or laying sort of on its side like a 30-degree angle. Way different results in the lightning protection system, how efficient that it was. As a blade moved from directly pointing straight up towards the sky where the lightning generator was, that worked pretty well. As soon as you start to rotate off of that, you start having big changes in the efficiency of the lightning protection system. So it points out a couple of things. It sort of highlights the really key facts here. All these lightning protection systems they were testing essentially have basically a cable, a copper cable running up and down the blade. And then they have something at the end of the blade. It would be a receptor or a metallized tip at the end. And that copper conductor, the down conductor that's stuck inside the blade, even though you can't see it, it's still active. Lightning can see that thing. It's essentially what it boils down to. Lightning can still see that thing. So as you move the blade from pointing straight up to pointing on its side, that cable, that down conductor in the blade is still as attractive as ever. In fact, it's probably working harder than the luminized tip or the single receptor at the blade end in terms of being attractive. That is a big deal, right? So what they were simulating in the lab is actually something we have seen in real life data coming back for the field, which is we're seeing lightning strikes on sort of standard blade protection systems where we have a receptor near the end of the blade. Those receptors aren't as efficient, and it looks like there's really two reasons why. One is the polarity, what the polarity of the lightning event is, because sometimes depending on how the cloud is formed, usually the positive is up high and then the negative charge down low in the cloud, but those can flip over, and there's a lot of variation in that. And then the second is just the orientation of the blade, where it is relative to the cloud seems to make a big difference. So it tells you that you really have to do your homework in terms of lightning protection. You need to be looking at not the easy configuration, which is point the blade up in the sky, see if something hits it. Yeah, okay, great, looks great. Off we go. What happens in real life and what they have found in this paper is that as you get in real world situations, the probabilities go down in terms of the efficiency, which means the likelihood of having some sort of structural damage to the blade goes way up.
Yeah. Just more variability of where it can hit it and just the way it's going to hit it and all that stuff.
Yeah. And I think the interesting thing about it is that I wonder if we ever get a chance to talk to these researchers to see what they would say. But I think from our experience, what you want to do on a wind turbine blade is start the ionization process and control where things start on the blade every single time. And that's what our strike tape product does. But that data also proves out when you don't do it. So if you don't control where things start, it becomes random. Yeah. It becomes random. And that's the trouble when you get randomness in any sort of thing, especially if you're talking about a 20-year lifespan and seeing a lot of thunderstorms and a lot of rain events and those sort of things. Eventually, over time, the odds don't get in your favor. It's unlikely you're going to make it 20 years without having some sort of lightning strike.
Yeah, for sure.
Yeah.
So with these down conductors, do they have any kind of shielding? Do they have any kind of insulation? I mean, can that be a potential improvement, or are they just completely bare copper wire?
They're both. It used to be that they were pretty much all just bare wire, or if they had some sort of insulation on them, sort of minimal installation, just for handling. And then they kind of get buried in or wrapped in the fiberglass of the blade. Sometimes it just keeps them from moving around. The thing you don't want is the cable constantly banging around back and forth on the structure, right? More recently, I've seen a lot of work done where they put a very thick plastic coating over that wire, so act as an insulator to try to prevent that wire from becoming energized and reaching out into space and trying to connect with the thunderstorm. In my opinion, it's going to be somewhat effective, particularly early. But over time, as things wear and tear, the insulation is not going to be, it's not made for this. Designing a piece of wire, designing a piece of wire, I don't care what the insulation is on it, designing a piece of wire with a piece of insulation on it, and in the hopes that lightning doesn't ever get there, you're going to keep things from getting there, is a little murky. I think the initial trials of it would make sense. Like if you took a brand new blade and you had a brand new cable and it's got this nice coating of plastic insulation over top of that down conductor, it's probably going to do pretty well in the lab. It may work, it may work great in the lab. But there's a lot of wear and tear on these blades over time. If that installation becomes damaged, and you're back to square one again. So the ultimate, we're going to have to let it play out a little bit. I think that's what I've seen some reports come back so far that has said it does help, but it's not completely eliminating the problem, which is punctures of the blade. So obviously anything you do to help reduce the cost or increase the survivability of the blade or reduce the number of damaging strikes, you should do. But there's also sort of a cost impact with trying to use a cable with a very thick insulator. So there's just differing opinions upon it. I think it can work in some aspects. I think it probably can't hurt. I just don't know if I rely on it for the next 20 years.
Yeah. Well, I wonder if, have you seen how they filled electrode junction boxes now in some situations with silicone?
Yes.
So that's pretty cool.
Yeah.
And you wonder if that could be applied. Obviously, like you couldn't do that over a whole blade because there'd be so much of it. But maybe if you had like a channel that the blade's in or that the conductor's in, you could sort of install it where it's fixed and then sort of fill it in with silicone or something. Yeah. I thought that was really interesting. That's like one of those, like, why didn't I think of this 20 years ago? Like you fill the whole box with silicone. And it's just impervious to everything.
Well, I think there's there's a sense of scale there, right? On household items, everybody thinks it has a little bit of voltage on it, 1,000 volts, 2,000 volts, 3,000 volts kind of thing. Those plastics can do pretty well there, right? And the problem with lightning is that the voltages get so dang high. You're talking about millions and millions of volts, and you're talking about a very tough environmental situation. That's where I start to scratch my head and say, plastics are not really made for this. Is this going to last all that long? We don't really have any data.
They last a long time in the ocean.
Yeah, right.
They last. Plastics, wherever you don't want them, they last.
Yeah. As we're finding with what's the name of the group that's out there recovering the plastics out in the ocean right now? Yeah, it's surprising. Yeah. I've been trying to follow those guys, Boy and Slat, and I can't think of the name of the place, but yeah, they're doing a lot of great work. And that's one of the things that I was talking to my wife about this the other day. Like, plastics are lasting forever. They've been in the ocean, hanging out there for years and years and years. Yeah.
Yeah. The baleen whales, they've got water bottles from 1975 still in their stomachs, unfortunately. That's terrible.
We got to do better, right? We got to do better. Yeah, we are. I mean, obviously, we're trying to do better.
Yeah. At least sea glass becomes, like jewelry 20 years later. The hippies can come claim it and we can repurpose it that way. But well, Alan, great episode today.
Thanks, Dan.
Good chatting with you. So we'll be back here next week on the Uptime podcast and probably dive into some more of this research because I think it's a good direction to go. And there's so much, with the spread of information with the old internets, there's obviously more sharing of information than there was, 20 years ago when a lot of these turbines
it's a lot easier to get
started.
A lot easier to get access to information now, no doubt.
Yeah, so absolutely. So if you're listening at home, thank you for being here. Be sure to subscribe to the show on iTunes, Spotify, wherever you listen to podcasts. Give us a subscribe and a like on YouTube because we obviously have video versions of all these episodes. And check out our Instagram page, LinkedIn, Facebook, Twitter for clips of the show. And thank you again, Alan, and we'll see you here next week.
See you next week.